Hello everyone, this is Huizhen. I will introduce you to a novel color image incubation scheme based on the chaotic sequence and DNA communication principle. I will introduce my research cells from four aspects. Based on the simple three-dimension functional uniform chaotic system and the principle of DNA communication, this paper a color image incubation method to further improve the security of image information transmission. On the other hand, the pseudomus sequence generated by the 3D so-called simple information systems uses the DNA communication principle, enabling to scramble the color image and expand the pixel value. Finally, the screening of the proposed calculate a subsystem is organized using by keys place, correlation, information informal. Numerical simulation results show that the results had good security. The results of this paper provide a similarity base for the innovation of the chaotic system, applying the principle of the fraction signal and DNA communication to image information. Next, I will introduce some basic theories. Table 1 showed only 8 of the 24 coding results meet the computed real, in addition to the recorded double ordination. In the process of the DNA sequence formation, a genome is paired and paired at the same time. There is a complementary pair of X, each base X and its paired base pair subset of following polynomial. This paper puts a fraction three-dimensional simple unified system based on the Lu system and Chen system. Here x1, x2, x3 are the chaotic state variables, where Q is the rank of the functional equation, C is the system parameter. Let the system pairs C link 0.9, Q 0.9, and the timestamp is 0.001 and the system integer value. At this time, the chaotic alters pace decrement and the sim is synchronous figure 1. At the same time, the output calculate since the system has only one positive output index value and the sum of the output index is negative, so the system is a chaotic state and the current condition, where the system pairs Q 0.1, the period window is only close to 0.84. Figure 3 shows the output candidate C buzzer and the diagram of the system. It can be seen from the above that the chaotic regions have the unity stamp with simple scores and described in a larger region. The number powers graphs of the coding logic system where C from 0.7 to 1.15. The induction NIST test is used to verify the randomness of the chaotic sequence generated by the laser chaotic system, preset the initial value of the system and each parameter and extract about 200 million values from the abundant chaotic sequence. Perform NIST test on the abundant sequence, then the test results need to compare with seized stat. The NIST test compares two standards to measure the randomness of the sequence. The first method is to test the path rate of random sequence samples and contain the test risk, where suppress the size of the random sequence down. If the result falls into the interval of the p, it means the sample is random. The sequence can be considered random where the p-value is doubt 0.001. The next values and roughly 200 million records provided by the system in this paper. Table list the test results of the NIST test. The NIST test results show that the randomness of the system is good. They are suitable for encryption anonymity. The imagine encryption and decryption scheme. The encryption attempt proposed in this paper with the introduction of the DNA mutation principle generally increase the randomness of the system, random scrubbing of the pixel, and the DNA definition. The first part uses a three-dimensional information from the chaotic graph to generate a random chaotic sequence, which will infer with the genus of the dimension. In the second part, three-dimensional fraction chaotic compose DNA coding operation and U2 generate chaotic sequence. The scramble channel perform diffusion operation. That is component incantation and communication operations. The figure shows the main encryption process. The decoding assumptions. First, use the communication process to recode the encrypted image into a DNA sequence matrix and perform reverse resorption. After reduction, the principle of the DNA separation and the principle of DNA computation, and you to obey the original DNA sequence of the encrypted image. Using coding recalls to reverse encode the DNA sequence, use the three-dimensional system to generate chaotic sequence and transform them into pseudo random sequence to restore the scrambling stamps of the encrypted image, obeying the original decryption matrix and encode it into a dynamical physical matrix and combine to obeying the decryption image. Finally, we pass the following test to vary the advantages of the procedure algorithm. A good image encryption algorithm needs enough key space to result brute force cracking. In our calculate, if the calculation cost is 10, the key place size corresponding to the key will be given. For the other part of the, because DNA has 4 kinds of size and bases, the key space is very big. The key place of the proposed algorithm is a large space. Therefore, the calculation must has enough space to result brute force Gaussian attacks. Another, in this experiment, the keys of the decryption algorithm was chunked, and then the encryption. Table 6 show the combination results. The test results show that the error decrypted image differs from the original image by more than 90%. Therefore, the encryption analysis will get a completely different decryption result if the key value is changed slightly. The history test is shown in the figure, and the experiment provides that the performance is good. There is a strong correlation between adjunct pixels of the information it stores. The performance of the image encryption analysis to break the correlation between adjunct pixels. The compilation formula for judging the pixel correlation formula is. The table data shows that the original image has a signal correlation, which the small correlation of the encrypted image indicates that in fact the encryption algorithm meets the requirements. In order to see more directly whether there is a correlation, the figure The figure shows that the correlation declaration between the level of the Lenna image and the adjacent pixels. As shown in figure, the original image has a strong correlation between adjacent pixels, and the small pixels of the original image are collected degree. However, as shown in the second half of the figure 6, the pixel decryption of the immaculate image is very uniform and will not be continuous, which greatly reduces the relationship between different component images in the encrypted image. Information equal decrease the uncertainty of the source. The average count of information of the all targets is the source, and is often used to test the confirmation of the image as shown in the table, where the combo probability of appear. The L is the number of the selected feature points million. Table shows the average information component of each image and the test value of the new combination meets the theoretical requirement. The test shows that the incorporated image is very chaotic. The information equals of other anonymisms is given in table and compared. Taking Lenna images for example, the results show that the encrypted image can be approximately recorded as a random image. This proves that supremacy of the anonymism. Sorry. Then I will test the different attack analysis in order to vary the sensitivity of the cheaper text to the Plaintext. We use the different to usually two standards pixel change that NPCR and Uniform Average Change Rate UACI, and commonly used to judge the performance of the encryption analysis. We test the 3 pixels channels of the image separately and average the result obtained. The table lists the results, and the table 22 lists the combination values of the other encryption analysis, which improves that the Randomness has classic information, zero security, and good performance beyond the classic image encryption analysis. Finally, we test the anti-noisy attack performance analysis. The integrity of 0.05, 0.06, 0.07 quantitative noise was added into the encryption process and decrypt the obtained image. The encryption results are shown in Figure 7. The test results provide that the anonymism has the ability to result noise population. Based on the ADM enzymes, the dimension characteristics of the 3D fraction schedule simple uniform system and its application in image encryption are studied. The chaotic states are described in a larger parameter range, which indicates that they are suitable for chaotic crypto systems. In this paper, we propose a new image encryption method using fraction chaotic system. The paper analyzes the security of the encryption analysis and applies the fraction simple unity statements and the principle of the DNA mutation to the image encryption implementations need to be improved. It provides a security and practical basis for the corrupted platform confidential communication and information security. Thank you.